up there's something I didn't take into account. We'll see. We're going to look at it later. All right, let's do this. Ready? Done. Okay. Using the fact that 1 plus x to the 4 times 1 plus x to the 9 is 1 plus x to the 13, show this fact. Okay. Now, by now, we know what 1 plus x to the 4 is when it's expanded, right? We understand to expand that, 1 plus x to the 4, it becomes 4, choose k, 1 to the 4 minus k, and then x to the k. We agree with that? Come on. Then we've got the same thing with the other one. 1 plus x to the 9, which becomes yeah, 9 choose R. That's what I paused for. Just trying to remember what it was. X to the R. We okay with that? And of course, in this case, it's also saying we've got 1 plus x to the 13, which equals to 13 choose, let's say, p, and then x to the p. We agree with all that? I seriously look at it, you're okay? Yeah. 100%? You could do that, because that's 1 mark already. Again, question 7. In the old HSC papers, these were the last questions. They're hard. Okay. Look at this for a second now, because that's what I've always tried to teach you. Look at your show. Especially that right-hand side. Look, there's only one component there. You think you know it? Yeah?
Many times this is using raised without pounds.
Oh,
so you would get 1 plus x equal.
No, but you're saying this becomes this. Not 4 plus 9 is 13. But that's a fact that they've given. They've already said using that fact. I'm more looking at, sorry, this stage now. This thing that we're trying to show. And I'm saying, look at this. This right here, the right-hand side. What does it say? Read it out if you have to.
P equals 4.
So read this component one more time for me. Just read that part.
It's 13 C4.
That is 13, choose 4. Correct? If that is 13, choose 4, what must P be? So it is telling you to equate, correct, coefficients without, like the other ones were telling you, hey, find the coefficient of this. So it's not telling you to find it. I mean, it's not giving it to you, but you have to realize coefficients, to equate coefficients of x to the power of 4. So how do we do these questions? It's always about the one that's by itself. The one that's by itself tells you your coefficient that you're trying to equate. Does that make sense? Once you know that, you're obviously going to multiply these together. So what's this? 4ck xk times 9cr xr. What must k be? Then r is going to be? Do you get that?
No.
K, if k is 4, you're going to get x to the power of what? If k is 4, you're looking everywhere. I can see your eyes. Don't need to look everywhere. Just here. If k is 4, you're going to get x to the power of 4. And then what should r be? So when you multiply these, you're still going to have x4. 0. If k is 3, what should r be?
1.
K is 2. Here it is. Ready? Look. 4 choose 0, 9 choose 4. 4 choose 1, 9 choose 3. 4 choose 2, 9 choose 2. 4 choose 3, 9 choose 1. Blah, 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 blah. All right. The guys here get it. You guys at home. Do we understand or are we confused? So 4 choose 0, 9 choose 4. Plus 4 choose 1, and I choose 3, plus dot, 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 dot. And then obviously equals eventually 13 choose 4. K is 0, R is 4. K is 1, R is 3, and blah, blah, blah. Andy, make sense? We've got 2 Andys, don't we now, actually? Andy squared. Yeah. Andy squared, does it make sense? Yeah. No, seriously, does it make sense, you guys?
Yeah, yeah.
Yep, you happy with it? We'll do another one. Write down what you need. Just because I can't do Saturday, so the Saturday class is coming.
So, in an exam, would you write it like that?
In an exam, would I write it like with the dot dot dots? No.
Oh, so it's like.
Yeah, I would hope you would write the whole thing because it says show this. Sam's lazy. You guys are not lazy. You're better than me.
I'm lazy.
All right, let's do another one. I'll do it properly, without taking shortcuts. I'll try. By considering 1 minus x to the n, okay, multiplied by 1 plus 1 on x to the n, or otherwise, well, definitely don't try otherwise, express this way, because what would be even the otherwwise? Like, how do you know where to start from? Let's go. 1 minus x to the n. All right, that becomes n choose k, 1 to the power of n minus k, which is nothing. Be careful here, negative x to the power of k. Any questions? At this stage, I pause, I just fix up the negative. We're not meant to have negatives like that. Negative 1 to the k, x to the k. Any questions here? No? Then we do the same thing with the other one. What don't we like about this bracket before I start? So what are you going to do? I like it. That's how I know you're ready for a question. You're meant to already know what the question, what to do before you even start. Think of it like that. All right. N choose R. Again, 1 to the n minus R. X to the negative R. Again, we'll just fix it up a little bit. Not that this needs much fixing. There it is. Okay, all good? All right, but now it doesn't tell me what to prove. It wasn't a proof question, right? So I don't have my right hand side. So the strategy I just told you guys above, unfortunately, cannot work right now because we don't know what it is. But we know when these two are multiplied, it'll look something like this. NCK, negative 1, K, NCR, and then X negative R, X, K. Just have a look, multiply them together. Do you agree with everything? I just put my numbers at the front because that's usually how it works, and then X is at the end. Again, next line. Just, I'm not doing anything fancy, so don't stress about it. X, bases are the same, I'm going to add my powers. So negative R plus K. I'll pause there. Any questions? Nope. Maybe there'll be a question now. Wait.
Where'd you get that from?
NCK, negative 1 to the K, NCR.
I didn't see that.
That's how much love I've got from my students. We'll do it. We'll talk soon. Hold on. We're at this stage. I told you got so many questions. Now, all right, stop. Now we look. Can you see how there's dot, dot, dots here? This goes on for, well, we don't know when to stop. But you shouldn't look at this. You shouldn't really look at this just yet. The one you should look at is the last one. Because that sometimes gives you a clue at what where you're trying to go with it, I guess. Compare. What's happening? Just compare the two. Really try to compare the two. Let's see if we can get it out. Let's see if I can get it out. So what is K? Yeah, that's the first one, but I said don't look at the first one. Hold on. I said look at that last one. You're missing an n minus 2, but then that's replaced for a letter, isn't it? So again, look at it. Yes, that's the one. Look at it. N choose N. N choose N. Negative 1k, negative 1k, negative 1n. So k must equal to n. K must be n. K must be n. R must be n minus 2. And let's see if it works out. X, so now you're about to find the coefficient of what? X to the power of negative n plus 2. Maybe you guys don't get where I got that from. That's R plus K. And that becomes negative n plus 2 plus n. So what are you actually equating? You just didn't realize that at the beginning. So now you've got to say equate x squares. Coefficients. Coefficients of x squared. So if I equate coefficient of x squared, what must k be? K is going to be 2, r is going to be 0. K is going to be 3, r is going to be minus 1. Or 1, sorry, no, you're right. 1. So then it becomes minus 1. And so on. Does that make sense? So once you equate coefficients of x squared, you might want to write, I don't know, k equals 2, r equals 0. Therefore you get n choose 2, n choose 0. K equals to 3, r equals to 1, n choose 3, n choose 1. And when k is 3, what's negative 1 cubed? Still a negative, and that's why that becomes a negative. You can see it all? And then really all you're meant to write at this stage is plus, dot, 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 plus, minus 1, n, n choose n, n choose n minus 2. Okay, so express this in its simplest form. We're not done yet. So now you just found out what's happening. You're pretty much equating coefficient of x squared. So now that we know what it is, we're going to go back on the top and...
Would you like to simplify NC1 to be n and NC0 to be 1? Is that what you mean by simplest form?
Say it again.
Like you may have NC0 is just 1 and
NC0 is 1 and n choose 2 is...
NC1 is n. Wouldn't you just simplify them? So it means by simplest form?
No. That means to get this into let's just say, it'll say 5. Pretty much evaluate it or simplify it as much as you can. So now we know what we're trying to equate. So hold on. Now we've got to think about. Okay, so now that we know that, hold on, now that we know that, this one here, from the original, 1 minus x to the n times by x plus 1 on x to the n. Yes? So, we're going to, yeah. Next line, 1 minus x to the n, 1 plus x on x to the n. I only did that so you guys realize that you can change the x plus 1 to 1 plus x. If I'm allowed to do that, can you realize that these two here is the difference of 2 squares? So this becomes 1 minus x n with 1 plus xn, and then still divided by xn. Next line. I've got to rub this bit out now, since I've already written the equate coefficient eventually. Hopefully I'm not doing this wrong. Feels a bit weird. 1 minus x squared to the n on x to the n. Still with me? Now, what is it? Yeah. And choose k, 1, and negative x squared to the power of k on x to the n. Negative x squared, negative x2k on xn. This will simplify to 2k minus n. I'm just trying to work it out in my head before. As long as this bit here is equal to 2. Whoa. Something's going wrong. Something's going wrong somewhere. Alright, let me think. By considering this, express this in its simplest form. So I expanded, I multiplied, I found k, I found the coefficients of x squared, n choose 2, n choose 0, n choose 3, n choose 1. All right, I'm missing something. Unless I wasn't wrong here. 1 minus x, x plus 1, 1 minus x squared, n, 1xn. You want to equate coefficients of x squared. N choose k, x negative 1, n minus k, negative xk. Oh, this is not going very well. Minus n plus k, minus 1 xk, and then that gives me x minus n plus k, but then you want that equal to 2. That's not going to work still. I'm missing something. Where am I going wrong?
I saw the day after. It was in Maverick TVs.
Yeah, I'm not wrong. I just didn't realize this was the actual last question of the HSC. This was the last one. It's four marks. So I'm not wrong. It's just I got to keep going. So before I do this, I need more space. So are we all good up to the stage we got to equate coefficients of x squared?
Yeah.
All right, here we go.
1 minus x squared.
Why would you only give like half a page? All right, doesn't matter.
If they were expecting the same handwriting,
Yeah.
Yes.
Okay,
Always-
please come on. Okay. So back to what I was saying. We found what we needed to find. We found equating coefficients of x squared. I might just copy that bit down as well so you guys don't get confused. There it is. Paste. Okay. There it is. Okay. Now, I need a right-hand side to this, right? So that's when you saw me doing what I was doing with this 1 minus x to the n with 1 plus 1 on x to the n. So now, last question. Last question meaning state rank, blah, 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 blah. But this is the actual last one. So it's not just the last question, it's the last part of that last question. So it takes a bit of time. All right, which I wasn't expecting when I'm doing it. 1 minus x to the n, 1 plus 1 on x to the n. Then I said that becomes 1 minus x to the n, x plus 1 on x to the n. And then I made it the other way around so you guys can realize the difference of two squares. Then that becomes 1 minus x to the n, 1 plus x to the n, let's say, over x to the n. Next line. 1 minus x squared to the n on x to the n. Beautiful. Then you saw what I did. They've got a common power of n. So I wrote it like this. So then that way I can bring this and go 1 on x minus x squared on x. This and this cancels out. Page. And page. Okay. So then we end up with this. So what we've just worked out is that this expression that they gave me originally, 1 minus x to the n. Hi.
Hi.
How are you? 1 minus x to the n can be written as that last line.
Yeah.
Yeah, you can just press that one, thanks. Or just turn it off. Listen. I don't think you want. So, you don't feel he asked? Huh? Same house. Goes on scarf. Really simple. Do
No, you guys don't want to ask about it, didn't
That's not cool.
you? You did.
So who's wrong?
All right, let's get back to it. So, yes, we're good with up to this stage, so that should be fine. And then we do it again. Just like, I just want to show you guys the difference between the two. So this one up here, they gave me the right-hand side simplified. So therefore I was able to quickly realize, okay, sweet, it's a coefficient of x4, done. This one here, I had to work it out myself, which we did. We found it's trying to say equate coefficients of x squared. Great, but I don't have a right-hand side. So what I'm going to do now is, I've simplified this expression. I've simplified the expression as far as I can to here. Do you understand the logic? So it should be the same, and then what we're going to do is, and choose k and everything again. So, equals, just so we don't get it confused, let's keep it like this, there it is. Oh, here we go. And choose k, x to the negative 1 to the n minus k, negative x to the k. That becomes nck x negative n plus k negative 1 k x k equals nck negative 1 k x negative n plus 2k. We're good so far? Okay, now I need this to be squared, right? So we want to equate our coefficients of x squared. So equating x squares. That means we want x negative n plus 2k to equal that. So negative n plus 2k equal to 2. Or in other words, if you want to solve for k, which is what you're meant to do, k must equal to 2, say again, 2 plus n on 2. So 1 plus n on 2 when you simplify. Okay, now n can't be what? Absolutely. What else? Now that you've got this result, actually it can be 0. What? Think about something. Say it again. It's not really technically a number like that. It's not like we're not looking for a number. Just look at this for a second. Think about what k is usually. Then there's a problem with the fact that it's written like this. What do you mean by that? Give me an. Okay, Mariette's saying k has to be a full number. It's called an integer. By the way. That's what a full number means, integer. So k has to be an integer. That is correct. What's the problem if I said n is 3? If I said it's a cubic, what's the problem? Is there a problem with n equals to 3? It's going to be 0.5. Can you have k equals 1.5? Have you thought of it yet? What n can't be? Yes. N can't be odd. Why can't n be odd? Because if it is, your k is always going to be a fraction. That should be right? K will not be an integer, blah, 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 coefficient will be 0. N is an even number, then the coefficient. I think we're pretty much there. So, n must be an even number. For n to be an even number, so n must be even. Right? That's the only conclusion that we've got. N must be even. So therefore, if I'm not wrong, we already found our k. The answer should be done. We're done. You ready? Yeah, you ready? Because you already got this. N choose k. So n, therefore, that's right. Therefore, the answer is n choose. What's k? 1 plus n on 2, as long as n is, where was I now? Negative 1 to the power of 1 plus n on 2. It's k. And that's it. And then x to the power of negative n plus 2k is obviously going to give you x squared. As long as n is even. Please. Well, yeah, like I said, we're talking about 99 to 100 again, this one. This one's not 90 to 95, it's the 9900. So to realize that step pretty much, you got to know the definition of the k. You got to be like, oh, the fact that it's n on 2, that's weird. I shouldn't have a fraction there. Because that means n is 1, won't work straight away. That's the first number that comes to my mind. 1 over 2 won't work. All right, so it is the same. It's just that's the only way they can make it harder at a band 6 level and whatever. So it's technically the same conclusion. Usually, look, the one above, we got to this level, and I said, okay, what must k be and r be so you can have 4? Well, you went, oh yeah, k must be 4, r is 0. Okay, k must be 3, r is 1. And so you're doing the same thing. You're like, as long as n is even, k will work out to be anything you want it to be. As long as n is even. And that's it. Interesting indeed. I'll leave that one. Okay, just by looking at the right hand side, you're going to equate coefficients of x to the n. Let's try it. Last one, I think it is. Yeah, last one. I won't do that one. Let's try this one. Okay, here we go. Using this fact, prove this. Again, let's start with the left-hand side. We get x plus x negative 1, n, which equals n choose k, x, n minus k, x negative k. X plus x minus 1, n equals ncr, x, n minus r, x minus r. Right hand side equals x plus x negative 1 to n, which equals 2n choose, let's call it p, x to n minus p, x negative p. Any questions at this stage? You know what you would usually do now? These are multiplied, so we're going to multiply these. We agree with that? So, the whole thing, everything. We're going to multiply all of this. Right? So it's going to look like this. NCK, NCR, X. What do you do with all the bases that are the same? We're going to go get n minus k minus 2k plus n minus 2r. That must be the same as 2n choose p, x, 2n minus p minus p, 2n minus 2p. Looks weird, I know. Don't stress, it will always be nice. NCK, NCR, x, n plus n is 2n, minus 2k, minus 2r. Now stop, you did all the hard work. You're pretty much, I guess, a step or two away. Look at this right-hand side. 2n, choose n. That's what we want it to be, right? So therefore you're going to say p is technically n. And look, it works out. 2p, 2n take away 2n is x to the 0. So if p equals to n, you're equating coefficients of, say that again. No, it's a 0. Yeah, weird, right? But let's have a history. Yeah. So it's just going to be the coefficient. So it's literally all your constants. So p equals to n, you get x to the power of 0. So technically you're equating constants, if you want to think of it like that, or you can say equating coefficients of x naught. So if you need to get x naught in this business, how does it work? Equals x to the 0, so we get 2n minus 2k minus 2r equals 0, as long as 2n equals 2k plus 2r, as long as n equals k plus r, you'll always get it to 0. We're still with me?
Sam,
Yes.
I didn't get how you made p equal to n. Can you just go through that real quickly?
Yes, of course. So one more time, look at, so always, because your left-hand side looks a bit weird. There's a lot of things happening. But your right-hand side, 2n and n. So 2n choose n. Here you have 2n choose n.
Okay.
So therefore,
okay. That makes sense.
the only way you're going to be able to get n is if p is equal to
Yeah,
n.
yeah, that makes sense. N, yeah.
Yep. Cool. Where was I now? 2n minus 2k minus 2r. Okay, n equals k plus r. So as long as your n is the summation of these two. So if k is 0, k is 0, r can be 10. No, something's going wrong somewhere. Again, not wrong. Just give me a second. Let me think. If I solve x equals sub x equals 0, no, I don't. Oh, no, I never do. So sub x equals 0, 0 times anything now is 0, so you don't want to do that. 2n minus 2k minus 2r equals 0. N equals k plus r. Whatever I used here, p. You're choosing your coefficients of x naught. Say that again. 2n minus 2k minus 2r. 2p. I can't see it. Right, that's what you're saying. Yeah, which means you get this result. P equals k plus r. But does that even help? If P equals to k plus r, I'm missing something. K plus r, k plus r, k plus r. Do you know how many times I've done this? A million times. There you go, shows you. Doesn't matter. If you don't practice it, I forgot it. It's the last time I did this routine like last year. So it's gone. Let me see. P equals k plus r. I know what's meant to happen. N choose 0, and then n choose k and r are meant to be 0. Then 1, 1 plus 1, 2. Oh, because they're the same. All right. You know how I did k and r here? You don't need to, because they're the exact same thing. with the other ones, just let's go because you guys are going to be like, oh, look, no, it's important. This one here, they're not the same. This one here, they're not the same. That's a 4, that's a 9. It is what it is. What can I do?
Well, which one's the same?
Here, but this right here. These two, they're the same.
Yeah.
So I shouldn't have done K and R. I could have done just K and K, which is fine. Easy fix. N equals K plus K, which is 2K. Or in other words, yeah, N equals 2K. Right? Because that would be minus K, minus K, minus K, minus K. No, because now you've got this. Sorry, don't ever do that. When you make a mistake, don't start at the end, start from the beginning, because there's probably other things you've done. So hold on.
So you're already.
No, I'm not rubbing everything. Just here. That's going to become a K, that's going to become a K, that's going to become a K. But what happens? This becomes minus K, minus K, minus K, minus K. So you'll get 2N minus 4K. 2N minus 4K. Can you see that? And then we'll go again. 2N equals to 4K when you equate it to 0. So N equals to 2K. Okay. Now, P, that's K. And okay, done. Right, ready? So here we've got NCK, NCK. So when K is 0, true, the different cases. When K is 0, you're going to get N choose 0 times N choose 0, which is N choose 0 squared. Plus, when K is 1, you're actually going to get N, hold on. Do we even need that condition, Sam? What do you think? 2N minus 4K equals to 0. What did I write? N equals to 2K. Because we're leaving N as it is. K is 1. The last term is yeah. So therefore, no matter what K is, when K is 0, when it's 1, N must be equal to 2. When it's 2, yes, okay. Yep, it's fine. N choose 1 squared plus N choose 2 squared plus ... plus last one is when K is N, which means N becomes 2N, which is the 2N that we have. So everything's working out. The last one should be N choose N squared. Your last K value is going to be N. Your last K value must be your N, the last term you're going to pick. Your first K is going to be 0, the next one's going to be 1, the next one's going to be 2, the next one's going to be 3, all the way up to N. And if we've done it right, if you can see, what did I say? I said if K is equal to N, yeah, K is equal to N, that means your last term is going to be your 2N's, which is exactly proving this. So the summation of all this is equal to the coefficient of this one of the first ones. So, yeah, you can see what I said with binomial the other day. That's it, yeah. Well, it says prove this. So all I was trying to do is just prove that NCK, NCK. And I can see that's N choose 0, then NC1, NC1, which is NC1 squared, plus NC2, NC2, which is NC2 squared, and so on. I just wasn't getting the squared when there was the R here. This is just a condition for this to occur. No, this one's not too bad. If I didn't break with the R, it would have actually, you guys would have get make sense. But because of the R, I stuffed it up and it's probably gone over there. But okay, now we're going with time. Yeah, cool. All right. Then let's do combinations. But we're not really going to do. Should we do the basic stuff as well from the beginning? Well, let's see. Yeah, we will. All right. How many ways are there to line up 5 students? You draw it up. 1, 2, 3. Oh, he's already done it. Yeah. 1, 2, 3, 4, 5, and then it'll just be 5, 4, 3, 2, 1. So that would be 5 factorial. In how many ways can a class of 16 select a committee consisting of a president, a vice president, a treasurer, and a secretary? So you've got 4 positions. 1, 2, 3, 4. That means 16 times 15. Make sense? In how many ways can 4 letters from the word bridge be arranged? There's nothing repeating, so the way it is 1, 2, 3, 4, and then it's just 1, 2, 3, 4, 5, 6, 6, 5, 4, 3. Times. Anyone not getting it at home? In a class of 30 children, 1 prize is awarded for English, another for science, and a third for mathematics. In how many ways can the recipient be chosen if no child can receive more than 1 prize? In a class of 30, 1 prize is awarded for English, another for science, and a third for mathematics. If no child can receive more than 1 prize. Does that make sense? Because 1 out of 30 people are going to get English, 1 out of the remaining 29 are going to get science, 1 out of the 28 will get math. A child can receive more than... Say again? If a child can receive more than 1 prize, that means, again, you've got 1, 2, 3. How many people can go in the first place? How many in the next one? So it's actually 32. Does that make sense? So there's more cases, so obviously, we're going to win more than 1 prize. Why don't you guys try those 2 questions? Let me just look at the question.
Is that our position? This is at least 1. A is 4, and B is 4. Because all 4 must be used.
Okay. Done? Stuck on B for the first one? 4 flags are used to send messages from a vertical flagpole. Find the total number of possible messages that can be sent if all 4 flags must be used. So 4 flags are used, and if all 4 flags must be used, Does anyone not understand A? 4 flags are used to send messages from a vertical flag or find the total number of possible messages that can be sent. 4 factorial. If all 4 flags must be used. 4 flags are used and all 4 flags must be used. If at least 1 flag must be used. Well, what do you think?
First it would be like 4 factorial and 2 factorial, 3 factorial, because it's like different cases.
Yeah, I like that. So go explain again. Yeah, you want to draw it up?
Well, it's at least 1, that means there can be, and at least 2, at least 3, and then there's 4. So it'll be 1 times 2 factorial times 3 factorial times 4 factorial.
Plus
Or plus.
1 plus 2 factorial. 4. No. Wait. Yeah. Yeah.
Yeah.
Find the number of possible messages that can be sent.
Each number of flags used.
Yeah, it should be plus. It shouldn't be times. So if at least 1 flag must be used, it would be 1 flag plus 2 flags plus 3 flags plus 4 flags. So that would essentially be 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. Any questions? Nope. 2005, extension 1 HSC. Have you guys tried that? Right. Sophie has 5 colored blocks, 1 red, 1 blue, 1 green, 1 yellow, 1 white. She stacks 2, 3, 4, or 5 blocks on top of one, on top of one another to form a vertical tower. How many different towers are there that she could form that are 3 blocks high? Me. It has to be 3 high, so you've got 5 times 4 times 3, that's what I would do. So you've got 5 colored, do you guys get that? So pretty much 5 letters, 3, you want to make a 3-letter word. So 1, 2, 3, how many different towers are there that can form 3 blocks high? That would be 5 to choose from, 1 red, 1 blue, 1 green, 1 yellow, 1 white, so 5 of the colors. 4 of the colors left, 3 colors left. So my answer for that one would be 5 times 4 times 3. And B, how many different towers can she form in total? Well, wouldn't it be now 5 and 4 plus 5 and 4 and 3 plus 5, 4, 3, 2 plus 5 factorial, which is the same. Do we agree? Stefan? No? Maybe? What? What's wrong? Because that's 2 blocks high, that's 3 blocks high, that's 4 blocks high, That's 5 blocks high. 5 times 4 times 3 times 2 times 1. Whatever that gives you. Any questions? So one second. Maybe I'm wrong. Maybe I'm wrong. The way I'm thinking of this is just it's a 5-letter word. And now we need to make a 2-letter word, a 3-letter word, a 4-letter word, or a 5-letter word. So it doesn't make a difference, but yeah, tell me now, what are you saying? Are you sure?
Yeah.
No, you want just ask, in case.
I thought it was something different.
No, yeah, she stacks a 2, 3, 4, or a 5 blocks high. So 2, 3, 4, 5. Stefan? Make sense? Okay. Deal with restrictions first, all the time, then arrange the remaining elements. All right, let's try. Again, maybe I'll give you guys just a few minutes to try this, see if you guys get a few things out, and I will do it myself as well. All right. In how many ways can 5 boys and 4 girls be arranged in line if the boys and girls alternate? Okay, I don't know if it was your class or the other class, but I want to make this clear. If it was 4 boys and 4 girls and the same question, this would be the answer. You would say boy, girl, boy, girl, boy, girl, boy, girl. So your answer would be 4 factorial times 4 factorial times 2. Why times 2? Because you could start with a boy or a girl. I hope you know with this one here, because there's 5 boys, you actually have to start with a boy. So you don't times by 2. So that would be the difference in the 2 questions. Please don't get them confused. Okay. So yeah, PG, PG, PG. 5 factorial times 4 factorial. Happy with that? 3 boys must be at the start of the line. If they must be there, put them there. And then and then if 3 boys must be at the start of the line, does that mean a boy can't be next to him? Not necessarily. It's just these guys have to be at the start of the line. So then we've got a boy. Sorry? They can't. It's saying they must be at the start of the line. Oh, those 3 can move. Yeah. Of course. We're going to do that in a sec. And then that could be a boy, and then boy, girl, 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 girl. So of course that would be 4 factorial times, no, sorry. This would be 6 factorial. Because these guys don't have to be in any particular order. They can just move themselves. Yes? So it won't be 4 factorial times 2 factorial. That would have been wrong. It's 6 factorial times these guys moving around themselves. 3 factorial. 4, 3, 2, 0. Greg, Ben, you guys got any questions so far? Everyone's pretty quiet. I'm not sure if you're getting it or if I'm losing people. You agree with everything so far?
Yeah.
Yeah.
Okay. For B, yep. I could put 5 boys there. Yeah, I could put 5 boys. But isn't this one? Wait. Say it again.
Because you have to put 3 boys in there, so you start with boys, so you put 5 boys there. and
5 boys where?
in the first position.
In the first position.
And then in the second, you put 4 boys, and the second,
But I'm pretty sure that's taken into account. So if you're going to do it that way,
and then you times by 3.
no, then you're doing this. Then you're doing 5, you're choosing 3, and you're multiplying that by 3 factorial. 5 choose 3 times 3 factorial times. So you've got 5 people, you're choosing 3, then these guys sit down, then this is, you've got 6 positions and you're putting 4 in. These guys got to take it and then times 4 factorial. Maybe something like that. What's the answer to that? 5, choose 3. Same? 1440. Hold on. I must have missed somebody. Just wait. 5 choose 3 times 3 factorial. Because it should be math. This is what I was trying to show you guys last week with that question. I said, I attempted it differently. The answer is, a different teacher attempted it differently. We got the same solution, just the way you're thinking about it might be different. Just wait, I'll get this one out for you. You said you want 5 boys. No, I'll explain that in a second. Hold on. 5 boys. 5 boys. I'm choosing 3. That's what you're saying. I've chosen my 3. Yes, I agree with that. Then these 3 can move. So then we're saying 3 factorial. I agree with that. Times now the boys, it doesn't matter where they sit. So these guys have to automatically sit in here. Times 4 factorial, 1, 2, 3, 4. The girl's moving. Then there's another 2 people that can move, which is what I'm not taking into account. Times maybe, yeah, times 2 factorial, which is just 2, which is what? 28, 80. I'm missing something there again for you, Rosemary, but it should work out to be the same. Hold on, I'll get it out. Give me a second. Give me a second. I'm just going to see 6 factorial working out. 5 choose 3 because you've got 5 boys. You're choosing any of the 3 to go here. The other 2 are automatically going to sit in these 1, 2, 3, 4, 5, 6 positions. So maybe in your method you'll do 5 choose 3 times 3 choose 3 times 6 choose 2 times 6 choose 2 no, 6 choose 2 I don't like times 2 factorial for sure. No, sorry, 4 factorial for sure. I'm trying, Rosemary. 5 choose 3. Let's go again. You've got 5 boys. You're choosing 3 to sit at the front. The boys must start at the line. Maybe actually 5. Choosing 3.
So what do you do? You're saying that you put 3 boys there,
Yep.
but you're not changing which boys can go there.
So Jack,
You know what I mean?
Steve.
Like
But aren't you supposed to designate what three boys and not like, we don't want these kinds of questions like.
Yeah, that's what I mean. Like you're already putting three people there.
You don't
But I
need
know
all,
what, but I know what you're saying. You're saying you have to choose. You have to choose the five. You have to choose your three out of the five. In how many ways can 5 boys and 4 girls be arranged in a line if 3 boys must be at the start of the line? So you're going to place 3 boys at the start of the line. That's what I'm trying to say. I don't think it matters which 3 boys, because the idea is I'm still interchanging these 3, and I'm interchanging these 6 factorials. So it doesn't matter if this boy was here, it's already included in my 6 factorial and my 3 factorial. Do you get what I mean? So, but your method should work as well. It has to. I can't see how to make it work yet. I'm trying to get the logic out for you. But it should work. It's just a different way of thinking about it. So what you do, you usually go, okay, 5 boys, you choose your 3. I'm okay with that. Then, those people are not moving, they're not moving. Then I've got 2 factorial, 4 factorial, 2 factorial, 4 factorial. If I choose 3 times 2 factorial, but you can't do times 2, I don't like it. I don't like it. No. I'm trying. I'll get it out. I'll try to think of your one. I will try my best to get B in a different way. But I know that definitely that's the answer for that one, because it's already included in the map. So you'll just be overlapping if I do my 5 choose 3. I'll go, okay, now also go 5 choose 3. But you've already chosen your 3 people in here. Does that, you get me? Yeah. I'll look at it again. I'll look at it again. Give me a second. Line begins and ends with a boy. Boy and boy. Begins and ends with a boy. So how many boys do I have left? I've got 3. So that means my 3 boys here, 4 girls here. These guys can be arranged in 7 factorial way. Times these 2 boys could change. And what you're saying is, I've got to go and do 5 choose 2. You see, it's not like that. If they need to be placed at the beginning and at the end, it's already included. Does that make sense? I don't know, someone else getting a different answer to me? Because I could be wrong as well.
What are the positions like first one, second, or the first boy and last boy, 5 times 4? Because 5 boys can go on the first and then 4 boys can go on the string.
I'm pretty sure it's a really different question. I know what you're saying. You're saying what she said. You just said 5 choose 1, and then you got 4. You 4 choose 1. Does that make sense? 5 choose 1, 4 choose 1, which is 5 or 4. I just don't. Let's hear from the others. Greg, what do you reckon? Am I doing this wrong? Well, how would you have done C?
That's the way I did it. I did 7 factorial times 2. That's the way I did it. But I'm not sure then.
Yeah. Let me think about it again, what you're saying. You're saying if the line begins and ends with a boy, you've got 5 that can go here. 4 that can go here. But then the problem is, if you're going to do 5 and 4, now you're not going to swap their positions. Do you understand that? So you're just doing different methods. So that's okay. Again, I should be able to get it out. 5 times 4 times 3 positions here, 2 positions here, 1 position here. How? How can you say that? It's not like that. I don't know if I like that, but I don't know. Does it give you the same answer? 7 factorial probably doesn't. 10,080. No, you're far off. I'm going to stick with my answers for now, and then I'll come back and think about the style of question you guys are raising. I know what you're saying. I don't think it's these ones. So I'll try. Maybe I'm completely wrong, and it is actually your way. How can we find this? Is it? Let's see. Mm-hmm. Mm-hmm. Official answer is only available to registered users, but I can just tell from the answer it's 7 factorial and times by what is
Oh, I got it.
what?
The White House. So,
Which is the same as my answer?
yeah.
But wait. Go.
So, I said put 5 in the first, then the second, then
5, 4, 3, 2.
times
Oh, B. Yes.
5, 4, 3,
Yes.
and then you can interchange them 3 times.
Mm, 3 factorial? Hmm? This answer is right from what I could see at the. Let's see if I can get another one. Maybe that one. 4 girls, 4 boys, 5 girls be seated. Does anyone have a different answer? Or you're just going to accept it? Because it looks like, from what I'm reading still, it looks like it's the same. 5 girls. Find the number of ways in which they can be seated. 2 girls are together and the other 2 are also together in the first 2. Yeah. Sorry? Yeah, the front door's closed. Yeah. It's open? Close it up, please. Twist to the right. Okay. I'm going to continue before we get everyone confused. And we'll try to come back to what you're trying to say. Girls are together. All right. So for the girls to be together, it's going to be G, 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 G in one big group. Then we're going to have 1, 2, 3, 4, 5, 6 factorial multiplied by 4 factorial. E, boys and girls are in separate groups. Well, what?
So they're sitting together and boys.
Ah, yes. If boys and girls are in separate groups, so it's going to look like this: girls, girls, girls. Yeah, and then it has to be boy, boys, boys. So that's 5 factorial times 4 factorial times 2 because these 2 can move. Okay with that one? Yes, Rosemary? Agree? F. Two girls, G1 and G2, are together. Well, these two girls are together. That just becomes 1, 2, 3, 4, 5, 6, 7, 8 times 2 factorial. And the last one, a particular boy insists on being between two girls. Alright. So that means the first one cannot be that boy. Can't be there, and he can't be there. So that boy cannot be there or there.
So can't
It
you
can't be
take
there.
1 unit as GBG?
Sorry?
Can't you make 1 unit GBG?
G, yeah, that's fair enough. GBG,
And just have them as that 1 unit?
but that's 1 unit. That could be,
Or actually, the teacher.
yeah, the two girls can. So it's going to be like this. It'll be 1 position, 2, 3, 4, 5 positions. So only 5 factorial ways times. The girls themselves can move in 2 factorial ways. And doesn't matter which girls we chose. These two can change. Pick one.
So then we have the option of 2 girls and
Hold on,
or boys.
hold on. So it could have been girl, girl, or it could have been girl, boy, or it could have been anything else. Alright, hold on. So in that case, the GVG, 1, 2, 3, 4, 5 factorial times 2 factorial for the girls moving these two.
I think it's part of the Zurich and the
Yeah.
See, because the thing is, even if this G was here, it would work.
Yeah.
Yeah. So just hold on.
Doesn't matter.
GVG. Yeah, correct. Yeah. So this could go 1, 2, 3, 4, 5, 6, 7. And then the girls themselves can move G ways, and I can't see anything else. That makes it a lot more. Now let's go back up to your B. 3 boys must be at the start of the line. Three boys must be at the start of the line. Let me see if I can get this out for you your way. 5. You can't say 5, 4, 3. Then you're doing it my way. You're meant to say 5, choose 3. You've got 5, you're choosing 3. And then, you know what? You know how I know you're even wrong? Because we're not even up to combinations yet. There's all meant to be permutations still. I know the logic's just not there. Like, it's meant to work out, but it's not yet, definitely not yet. Enough. We've overkilled it. We see we're at permutation. It's done. All right. Let's go again. Example 50. How many ways are there arranging the letters of the word meals? If the consonants are to be grouped together. Well, I think we know the answer to that. 1, 2, 3, 4, 5. Consonant, consonant, consonant grouped together. So 3, 4, 5. So 3 factorial times 3 factorial. If the vowels will be at the front and the back, if they will be there, just put them there. E and A, so that's 2 factorial times 3 factorial. That was easy. I'll move on from this one. So easy, easy. We know what to do with repetitions of letters. We're going to divide it out. Okay, so yeah, let's do this one. How many 5-letter words can be formed by using the letters of the word banana? No. 1, 2, 3, 4, 5, 6. You've got 6 letters. And you want only a 5-letter word. The reason why I'm looking at you like that is you've got 3 A's, you've got 2 N's, and then you've got 1 B. So you can get a 5-letter word. So case 1. You can get literally 3 A's, 2 N's. You could get 3 A's, 1 N, 1 B. Case 3, you could get, that's it. You can get 2 A's, 2 N's, 1 B. You could case, that's it. Case 4, you should get 1 A. No, that's it. There is no, that's it. Oh no, wait, case 4, 1 A, 2 N, 1 B, and then 1 possible. That should be it, right? Can anyone else see any more? All right, that's it. So the answer is, so we've got 1, 2, 3, 4, 5-letter word, and it's going to be 3 A's, so it's going to be 5 factorial over 3 factorial, 2 factorial. This one's going to be 5 factorial over 3 factorial, and this one's obviously 5 factorial over 2, 2. It's not 6, 5, 4, 3, 2 then. A lot of kids think so. They're all plus. Correct. That makes sense? Let's try it again. Hopefully there's another one. Move on. Scroll up. Did I miss something? No? All good? Okay. Circular arrangements, we subtract 1. Fix the location of someone. Draw the picture. Alright. Let's try this one. 4 boys and 4 girls are arranged in a circle. How many ways can this be done? No restrictions. 7 factorial. If the boys and the girls alternate, remember you sit someone down. 1, 2, 3, 4, 5, 6, 7, 8. Get someone sitting down and then it'll be boy, girl, boy, girl. So it should be 4 factorial times 3 factorial. Are we okay with that? If the boys and girls are in distinct groups, that means in different groups again. So that means like this. And like this. Right? That's how I understand distinct groups. So my answer for this would be just 4 factorial times 4 factorial. The reason why we don't need to times it by 2 factorial because you're going to go times 2, but then because it's a circle, you're going to take away 1 anyways. So it's technically just 4 factorial times 4 factorial. Say that again? Yeah. Yes, if it was in a line, we would times it by 2 factorial. Do we agree with that? Because they could move around. Good. Looks like Rosemary's got a question. You sure? If a particular boy and girl wish to sit next to one another, well, there they are. They're going to sit next to each other. And then it's going to be 1, 2, 3, 4, 5, 6, 7. So 6 factorial times 2 factorial. If two particular boys do not wish to sit next to one another, well, assume they are sitting next to each other, like these guys were. You mean the total minus. Total minus. 1 minus is for probability. The total is 7 factorial minus. 7 factorial minus 6 factorial times 2 factorial. So you'll do it as if they were to sit next to each other and then subtract. See you, Alessandra. If one particular boy wants to sit between two particular girls, if one particular boy wants to sit between two particular girls, let's go again. If one particular boy wants to sit between two particular girls, yeah. Please. One particular boy wants to sit between. That means boys there, girls here, girl here. And here we go. 1, 2, 3, 4, 5, 6. So 5 factorial times the girls switch places. You happy with that? Thank you. All right.
When your students are done, get them to do this. No, it's actually not really. I will the final question. This is the entrance exam that I do.
Interesting.
It's from the 1800s.
From the 1800s.
Oh,
All right. 7 people are sitting around the table. How many sitting arrangements possible? I think these are easy now. Let's move on. How many can people across 2 tables, each sitting 5 people? Move on. 4 married couples. We like married couples. And how many ways can this be done? No, that seems easy. All right. Combinations. We got there. Now we're doing permutations. That's why they're all factorials. Okay. Find how many possible combinations there are if from a group of 10 people, 2 people are chosen. Well, 10, choose 2. 8 people are chosen. We've got 10, we're choosing 8. Why are the answers identical? Because of symmetry properties in Pascal's triangle. Move on. A security lock has 8 buttons labeled as shown. Each person using the lock is given a 3-letter code. How many different codes are possible if the letters can be repeated and their order is important? If the letters can be repeated, well, it's a 3-letter code. Sorry? Technically, it's okay, because a HSC question. If it's a 3-letter code, letters can be repeated, what's the first digit? How many numbers can go in the first? How many numbers do I have to pick from that can go in the first digit? The next one? Because it can be repeated. How many different codes it cannot be repeated? 8 times 7 times 6. And then now suppose that the lock operates by holding 3 buttons down together. So the order is not important. How many different codes are possible? Haha, wrong. How is that different? It's interesting actually, because I think that's the biggest difference between a permutation and a combination. I obviously said the answer. Yeah, so what you're doing this time, imagine these 8 things in front of you, 8 buttons, and you're doing this. You're getting your 3 fingers and you're just pressing at the same time. So you're pressing 3 at the same time. The order doesn't matter. You're just going. Yeah. But I'm just trying to tell you the difference between the two. If you chose A, you clicked on that, then you clicked on this, then you clicked on this. That's different to clicking it all at once. Okay, move on. Still, any questions? All right, let's do. I'll probably want to do that one. Let me just see what else is left. It's something that's got answers, so we can make sure we're doing it right. All right, let's try this one then. 10 people meet to play doubles tennis. Okay. in how many ways can 10 people, in how many ways can 4 people be selected from this group to play the first game? Well, what do you mean by that? It just says 10 people, there's just 4 people. So you're going to go 10, choose 4. B. How many of these will include Maria and exclude Alex? I know, right? Well, the idea is if Maria's already included, so there's 10 people. If Maria's already included, then that means there's 9 people, and you're, wait, there's 9 people, and you're still selecting 4. No, sorry, you're selecting 3. 3, because you've already chosen Maria. But then you've got to exclude Alex now. So how many people are left now to pick from? 8. And you've got to choose 3 still. Does that make sense? Is right? Looks good. C. If there are 4 women and 6 men, in how many ways can 2 and 2 be chosen from this game? Well, I think that's very easy. That's going to be 4 choose 2 times 6 choose 2. And D. Again, with 4 women and 6 men, in how many ways will women be in the majority? So for women to be in the majority, it would have to be 4 choose 4. Do we agree with that? 4 women choosing 4 plus 4 women choosing 3 times No. Wait. Oh yeah, there's a majority, that's it. That's right. 6 choosing 1. 6 men choosing 1. There shouldn't be anything else. Plus 4 choose 2, but that would not be in the majority, so we're good. And whatever that gives you, 25. All good? CWSA, let's try this one, 2012. From 6 girls and 4 boys, a committee of 3 girls and 2 boys is to be chosen. How many different committees can be formed? Well, again, it's just going to be 6 choose 3 times 4 choose 2. Again, whatever that gives you. Easy, move on. Probably the same, move on. Probably the same, move on. Does not look the same. Let's try that. The extension 2, we try it?
Yeah. Let's do
Let's do this one first. This one looks harder. 10 points, P1, P2, all the way to P10 are chosen in the plane. Note 3 of the points being collinear. Okay, so they're not collinear. Cool. How many lines can be drawn through pairs of the points? How many lines can be drawn through pairs of the points? What is it? Lies on the same line. Yeah, because that's kind of out of the syllabus, isn't it? Collinear. But lies on the same line. That's what that means. So no 3 of the points lie on the same line. How many lines can be drawn through pairs of the points? So let's think about this. You've got P1, you've got P2, you've got P3. Well, let me start again. I stuffed that up a bit, but it's okay. I did it on purpose. P3, P4, P5, P6, P7, P8, P9, and let's just say somewhere there is P10. P10. And you can see I can't draw a line going through 3 of them. So they don't lie on a line. That's why I drew this particular shape. It's not collinear, in other words. How many lines can be drawn through pairs of the points? Okay. So can you see that would be 1 pair? Then I could also draw that one. I could draw that one. Then I can draw that one. Then I can draw that one. I can draw that, that. Can you see that? And I can keep doing that a few times. So what would that be? That would be, just so you guys can see, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly. Can you see the next one? Well, you've already gone through this, so you're not going to do it again. 1, 2, 3, 4, 5, 6, 7, 8. And I think we now know it. 7 factorial. So a little bit different. I think drawing the diagram really helped, but if you've never seen a geometry question like this before, you wouldn't know to draw it like that, so that's okay. B. Yeah, so 9 factorial in other words. How many triangles can be drawn using the given points as vertices? Okay. And again, 1. Yeah, here. These. True? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8 triangles for P1, P2, P3. Then P1, P3, P4, and so on. You agree with that? Wait. And then what if I started with P2? How many triangles will I get there? Let's just make sure. So you guys can see it. P2. There's 1, 2, 3, 4, 5, 6. That's a triangle. Yeah, P2, P9, P10. And that's it. Alright, now that you realize it is 7 factorial, I think we're happy to say that. Oh, be careful. With a triangle, I just want to make sure. So I'm happy with 8 for that. Just want to double check what I just saw in case. 8, 7, 6, 5, 4, 3, 2. No, you're right. I'm happy. Because the problem is if you're going to get to P9, if you get to P9, you're going to know that these two won't form with anything else by themselves. But it actually stopped here, which is perfect. It stopped at P8, which is going to do that. See that? P8, P9, P10. So that'll be the last one. So that's good. All good. 8 factorial in other words. C. How many of these triangles have P1 as one of their... Well, how many of these triangles have P1 as one of their vertices? It should just be 8. Right? Am I wrong? Maybe no, there's more of them. There's plenty more. Because it should be P1, P2, P3, P1, P3, P4, P1, P1, P1. Then it'll go P3, P4, P3, P5, P1, P3, P6, P1, P3. You get me? So it'll be P1.
But if one goes out, so it'll go first.
Say again?
From P1.
P1 goes to P3.
Yeah.
That's 1.
Yeah.
Then 2, 3, 4. So we said 8.
So
Then. But then that's only, but I'm only doing P1 to P3 like that.
Yeah.
But I'm missing this one here. Hold on. I'm missing P3, P5, P1. Whereas the one we've done was this. Which actually might mean I've also missed some triangles. Haven't I? Now that I realise. Because isn't this a triangle?
Yeah.
Indeed. Yeah, about that. All right, let's think.
How can we say it?
No solutions? Let's see.
Is there no solution?
That's fine.
That's
I like to test myself. Clearly I failed. 10 points. Where are we? Which no 3 points. The number of straight lines from the given points. 10 times 9. What the? Who's writing this? And the number of straight lines from the line 12 C2 10 minus. Unless he's doing 10 choose 2 minus 4 choose 2 plus 1 since 4 points are collinear line equals 10 times 9 2 minus. But it looks like I found the question. The number of triangles formed with no collinear C36. The number of triangles formed with 1.8. Why do you have to write so weird? Okay, let's try to get it out.
C1.
I think this is saying 6 choose 3. The number of triangles formed with 1.8 from 4 choose 1 times 6 choose 2. Then 2 points taken from 4 collinear points. That's the number of triangles are. 6 times 5 times 4 times 3 times 2 plus 4 times 6 times 5 times 2 plus 4 times 3 times 2 times.
Why is he writing like that?
I don't know. I hope this helps. Oh, it doesn't, man. Alright, since there are no points, total number of triangles. Here we go. Therefore, total number of triangles is 10 choose 3, 10 factorial, 10 times 9 times 8, over 3 times 2 times 1, 120. Total number of triangles. Sorry?
You were right off that.
The repetitions, huh? Yeah, we were way off that. But see, this person got 116, so they've got different answers. Yeah, obviously it's not combinations. How many different triangle combinations? What is that? We are. What?
We're watching over 2 hours.
Oh yeah, exactly. Part of problem solving, 10 points in the plan are given with 3 marks.
Do you find this through HSC questions? I found something.
Since none of the points are collinear, it is possible to pick 10 choose 3 sets of 3 points which form the triangle. Since the triangle comes with 3. To form a line, we need to select any 2 points and then join the subtiles. Once we select the point, there is only one straight line which will be formed using the point. 10 choose 2 times. Since 4 particular points are now collinear, there will only be one line. What about all the other triangles? Suppose all points are now. Is that it? So this probably says it the easiest way. Suppose all the points were non-collinear. The number of triangles would have been 10 choose 3. I would have thought that as well. It's because to form a triangle we need to select any 3 points. Out of 10.
How about if only 2 of the points?
Well, what is 10 choose 3? So it's 120?
Yeah.
And what happens if on the start you didn't draw it in that way? Like, wouldn't you get a different amount of time and stuff?
Well, here's the one that these guys did.
And then about that,
Yeah, like that's 1 point, that's another point, that's another point, that's
I
another
thought
point.
it was just.
And
yeah, Sam's really bad.
Because
Since
it's
the door is set up.
I can't say the word. Specifically, learn through the points of being collinear. So how about if 4 of the points are collinear?
that's what it said. That was that case. This one, they've drawn that there. 4 points per linear.
So I should know.
How many lines can be drawn through pairs of the points? How many triangles can be drawn using given points as vertices? So that one's saying it's 10, choose 3. Any 3 points, draw a triangle. How many of these triangles have P1 as one of their vertices? How many of these triangles would have P1 as one of their vertices? Well, how many is repeating? How many of these triangles have P1 and P2 as vertices? You're going to choose these two. So C should be 9, choose 2. I actually get what it's saying now. D, it wasn't the way I'd all read this. D should be 8, choose 1. So, let me start from D. How many of these triangles have P1 and P2 as the vertices? So P1 and P2 are the vertices of the triangle. You've got 8 other sides you can pick from. Yes? And you're choosing any one. Does that make sense? You've got 8 other sides, you're choosing one. Does that make sense?
Yeah.
Right, let's say, look at it again. Yeah. How many of these triangles have P1 as one of their vertices? If P1's already at the vertices, I've got 2 other vertices to pick from. It doesn't matter what it is, P2, P5, P6. I've got 9 of them to pick from as well.
So if this is
B, how many of the triangles can be drawn using the given points as vertices? 10 choose 3. A is the one I'm trying to work out now. How many lines can be drawn through pairs of the points? How many lines can be drawn through pairs of the points? Well, did I overlap anywhere? Pairs, just pairs, right?
But then can't that be
No, not a triangle, this is just a line. How many lines can be drawn? Let me just make sure. We're saying this, this, this. This, this. Same as that. Whereas what we just did, I just said, oh, it's 1, 2, 3, and then I went 2. And then here, I've already taken into account P1 and P3. So there's P3 and P5, and then that means P5 will have 1 less. Yeah, I'm happy with my first one. I can't see any other lines working out. So it's a lot. So the first one should have been what, 9 factorial? Why does it feel so large?
It makes sense.
362,000 lines that can go through. Well, give me a second. Let's just say if there was 3 of, I think that's the best thing. Imagine there was 3 points. If there was 3 points, P1, P2, P3. P1, P3. Hold on. 1, 2, 3. That's it, you will only get 3. If it was 4, 1, 2, 3, 4, P1, P2, P3, P4, you only get 1, 2, 3, 4, 5, 6, and that's it. So 3, for 4 it's 6, so it's what? 3 choose 1, 6 choose 4.
All we're doing is basically you have to minus the total number and plus on the
I think you're subtracting 2 for what it looks like. So I think the answer to this is actually 10 choose 8. But that's so small. No, that doesn't make sense. 45. I think the answer is 45, but I'm going to double check and see if it works out. Instead of 9 factorial. I don't like 9 factorial anymore. Hold on, I'm going. 5. If there was 5 dots, P1, P2, P3, P4, P5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Have I missed any? P3 to 10. No, that looks right now. But it's a star inside. So that should be 10, which I'm saying is the same answer as 5 choose 3. Is that right? What's 5 choose 3? 10. I got it out. Ugh. That took forever. A, the answer is 10. Choose 8. 2 less. Ready? If you had 3 points, choose 1. Gives the answer of 3 lines. If I had 4 points, I got the answer being 4 choose 2, which is 6. 1, 2, 3, 4, 5, 6 lines. So 2 less. Again, can you see that? Next one. If I had 5 points, 1, 2, 3, 4, 5, I draw it all out. I had 10 lines, which is 5 points. I choose 2 less, 3. The logic, I gotta find out. I don't know where to find that logic from, but I found the pattern. So the answer to the first one has to be 10 choose 8, which is 45. Yeah. So again? I know, right? But I think that there's going to be that overlapping. Well, you know what we did wrong, I think? I think it's 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1.
1 minus the total plus each other. Yeah.
I don't know, why did we say 9 factorial? That's what it should have been. It should have been 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. That actually gives you 45 as well, you guys. We weren't wrong the first time. It's just that I don't know why we thought of time. Oh, good. All right. I'll leave it there. We'll continue. I think we should be up to pigeonhole principle soon. Our probability, and then hopefully pigeonhole. There it is. And then we're done. We're all very close to finishing this off. All right. If you've got questions,